Today we are going to be working on solving rational equations. So solving rational equations, we're going to start by looking at the denominator. Any restrictions that you might have come from having variables in the denominator. So since the only variable that we have here in the denominator is x is not allowed to equal 0. We have a fraction equals a fraction, so we can cross multiply. So 10 times x is 10x, and 2 times 13 is going to give us 26. This type of solving rational equations problem you've done before in Algebra 1. So as long as you have a fraction equals a fraction, you can cross multiply and then solve whatever type of equation is left. So you might have a two-step equation left over, a one-step equation. You might have to simplify a fraction. You might have a quadratic where you have to factor. So anything's on the table here for these types of equations. Please just remember that cross multiplication is only when you have one single fraction equals one single fraction. If there's other stuff going on, we're going to have to do something different. So to jump back to this problem, we would need to multiply out that 2 times 13 and get 26. We divide by 10 on both sides. I do not like decimals, so I'm going to leave this as an improper fraction. I'm just going to simplify 26 tenths. Those are both divisible by 2, so 26 divided by 2 is 13, and 10 divided by 2 is 5. That improper fraction, 13 fifths, is not a restriction. It's not 0, so it works. In this example, we have no restrictions because we do not have variables in the denominator. Here's another example where we can cross multiply, but be careful here because when you do 5 times x minus 1, you need to distribute the 5 to the x and the 5 to the negative 1. So 5 times x is 5x, 5 times negative 1 is negative 5, and then 2 times 15 is 30. We just solve like we would a regular two-step equation by using inverse operations. We end up with x equals 7, which is not one of our restrictions because we did not have any restrictions in this problem. So cross multiplication is only for when you have a fraction equals a fraction. We're going to look at another example where you don't have a fraction equals a fraction. You have some other stuff going on. You have a fraction minus a fraction equals a fraction. So we need to find the least common denominator. Before we do that, we need to find the restrictions. So I look at the denominator x plus 2. If I set x plus 2 equal to 0, I would subtract 2 from both sides, and I would get negative 2. When I look at this x is not allowed to be 0, and when I look at 5x, that would give us the same restriction, x cannot be 0. Now I need to find out what the LCD is. So the LCD is like, what would my denominator be if I wanted them to all have the same denominator? So I would need a 5x in there, and I would need an x plus 2. You can't multiply anything by x to get x plus 2, so you would need to multiply those denominators by each other. You could multiply something by x to get 5x. The LCD is going to be the hardest part for you, but once you figure it out, you'll see that this is just like simplifying rational expressions. So here I'm just kind of rewriting the equation and spreading it out a little bit so that I can multiply each fraction by that least common denominator. So I'm not trying to get the denominators the same. My goal here is to try to kill the denominators. I want those denominators to go away because I want this to just be a regular solving an equation problem. So I'm just multiplying each and every fraction by this least common denominator. I didn't mean to put parentheses around that 5x, but it doesn't matter. So in the first expression, the x plus 2's can cancel so that all that's left is 5x times 3. In the second expression, the only thing that you can cancel is the x over x, and in the third expression, you can cancel out the 5x with the 5x in the denominator, so that what's left has no denominators left. In that first expression, you have 5x times 3 left over. In the second expression, you have minus 1 times 5 times x plus 2. I don't really need to write the 1 there. You could if you wanted. And then in that last term, just x plus 2 times 1 is left over, which is just x plus 2. So I don't have any more denominators. This is good. So my goal in step 2 is to multiply each fraction by the least common denominator so that I can kill the denominators. I do not want any fractions after step 2. I want all those fractions to be gone. So if you still have fractions left, that means you didn't cancel right, or you didn't find the least common denominator. So here I just need to simplify. 5x times 3 is 15x. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. And then I have that x plus 2 at the end. I can combine like terms. And then I have a multi-step linear equation to solve. So I want to get my x's together. I like to try to keep those positive if I can. Get my integers together. And then I can simplify 10x minus x is 9x. 2 plus 10 is 12. I divide by 9 on both sides. And I don't really like decimals, so I'm going to just simplify this fraction here. Divide both by 3. 12 divided by 3 is 4. 9 divided by 3 is 3. And I want to check that very last step to make sure that my answer is not a restriction. And thankfully, 4/3 was not one of my restrictions, so 4/3 is a valid answer for number 3. Let's look at this example. I want to state my restrictions. The only thing in the denominator is x, so x is not allowed to be 0. I could technically cross multiply here. I could put that x plus 1 over 1, and I could cross multiply, or I could find the least common denominator, which is just x, and multiply both sides by x. So x over x cancels out, and then on the left, nothing cancels out, so I'm left with x times x plus 1, which would be the same thing as cross multiplying. So what you're doing when you're cross multiplying is you're taking a shortcut. You're multiplying by the least common denominator, but you're cross multiplying instead. So here, a little tricky, you do get a quadratic. X times x is x squared, x times 1 is 1x equals 72. I'm going to need to subtract 72 from both sides because the only way that I know how to solve a quadratic is by factoring and setting each factor equal to 0 or using the quadratic formula. So I don't know about you, but I don't really want to use the quadratic formula if I don't have to. There's a lot of steps involved. Instead of using the quadratic formula here, I can find two numbers that multiply together to give me negative 72, but add together to give me 1. So 9 and negative 8 would multiply together to give me negative 72, but add together to give me positive 1. The last step is to check to make sure that your answers are not one of your restrictions. I have negative 9 and 8, and my only restriction was x cannot be 0. So both of these answers are valid. All right, let's try this one. You want to find your least common denominator. You want to state your restrictions, and then you want to go ahead and follow those steps. So try a little bit and come back to get a little hint. All right, so your hint is to look at all of your denominators. Look at the first one and read it. X times x minus 2. I can read and hear x times x minus 2. So I can multiply something by that middle denominator to get x times x minus 2. And I can multiply something by that last denominator to get x times x minus 2. So that's my least common denominator. From this step, see if you can cancel, write what's left, and solve from here. Pause the video, come back when you're done. All right, so in this first fraction, I can cancel out the entire denominator so that all that's left is 10. In the second fraction, only the x's cancel out, so all that's left is 4 times x minus 2. And in the last fraction, the x minus 2's cancel out, so that all that's left is 5x. You solve this like you would a regular multi-step equation. You distribute the 4, you combine like terms, you use inverse operations, and you end up getting x equals 2. X equals 2 is one of my restrictions. So here, when you have an answer that matches your restriction, it cannot be a solution. Since I have no other options, my answer is no solution. In this next example, we see that we have a quadratic trinomial in the denominator of our last fraction. So we need to factor it. There should be like a little trigger in your brain that sees that x squared minus 6x plus 8 and is like, I need to factor this. Numbers that multiply together to give you positive 8 but add together to give you negative 6 are x minus 4 times x minus 2, which is our least common denominator. Because x minus 2, I can multiply by x minus 4 to get x minus 2 times x minus 4, and same with the middle term. So my restrictions are x cannot be positive 2 or positive 4. You get those by setting those least common denominators equal to 0. I'm going to just spread this out a little bit. Notice how I'm going to write my factored form of that denominator and not the original form. When I multiply each piece by the least common denominator, I should be able to kill all the fractions. So this first fraction, the x minus 2's cancel out, the second fraction, the x minus 4's cancel out, and the third fraction, the entire denominator cancels out with the entire least common denominator. So that all you're left with in the first term is x times x minus 4. You're left with 1 times x minus 2, which is just x minus 2, and you're left with 2. You're going to have to distribute that x. X times x is x squared. X times negative 4 is negative 4x. And then we can combine like terms. Negative 4x plus x is negative 3x. And we have minus 2 at the end. This is a quadratic, so I want this to equal 0. So I need to subtract 2 from both sides. From here, you get x squared minus 3x minus 4, which you can factor. When you factor this, it factors into two numbers that multiply together to give you negative 4, but add together to give you negative 3. So x minus 4 and x plus 1. When you set these both equal to 0, you get positive 4 and negative 1. Positive 4 was one of our restrictions, so positive 4 is not allowed to be one of the answers. But here I have another option for an answer. I have x equals negative 1. So that is the only answer that is valid here. For this next example, I want you to try it. You're going to have to factor that denominator first. Look for a GCF. Find your restrictions, find your least common denominator, and then try to follow the recipe. Pause here, try it, and come back when you're done. That first denominator has a GCF of x, so if you factor out an x, you're left with x times x minus 5. That is your least common denominator, and your restrictions are x cannot be 0 or 5. When you multiply each one of those fractions by your least common denominator, you should have no more fractions after this step. Once you cancel out all those like quantities, nothing cancels out in that last term because you don't have a denominator. You have a denominator of 1. So you're left with this. You're going to have to FOIL that x plus 7 times x minus 5. So x times x is x squared, x times negative 5 is negative 5x, 7 times x is 7x, and 7 times negative 5 is negative 35. Then we have to distribute that negative x to x, which is negative x squared. Negative x times negative 5 is positive 5x. Here you are combining like terms on one side of the equal sign. You do not use inverse operation to combine like terms. You're just doing negative 5x plus 5x, that cancels out. X squared minus x squared also cancels out. So you're left with 7x minus 35 equals 1. So you have a two-step equation to solve. This is where you use inverse operations to solve for x. You end up with 36 over 7. That is not one of your restrictions, so this answer is valid. Here is another one to try. See if you can factor anything in the denominators, find the restrictions, and find the least common denominator. Pause it, try it, come back when you're done. That first denominator, you can factor out a 5, and that last denominator factors into x plus 2 times x plus 1. So in my least common denominator, I have to include that 5, the x plus 1, and the x plus 2. 5 does not give me a restriction, only x plus 1 and x plus 2 give me a restriction. When I multiply every single fraction by that least common denominator, I should have no more fractions left after I cancel like quantities. So in that first one, I can cancel out the 5s and the x plus 1s. The second one, I can cancel out the x plus 2s. The third one, I can cancel out the x plus 2 and the x plus 1, so that I'm left with this. I need to distribute everything and simplify everything. I'm solving for x. I end up with a quadratic, so I need to get everything moved onto one side, and I need this equal to 0, where I can factor and I can set both of those factors equal to 0. This factors into x minus 5, x plus 2, because negative 5 plus 2 is negative 3, and negative 5 times 2 is negative 10. So I notice that one of my answers is a restriction of negative 2. So the only answer that is valid here is x equals 5. There are so many more examples, I couldn't possibly show you them all. So practice, and I'll see you next time. Bye.